In my last video, I explained that subshells contain orbitals, and the s subshell contains one orbital per s subshell, and the p subshell contains three p orbitals per p subshell. And so in this video, what I'm going to be doing is looking at the actual shapes of these orbitals. Now the s orbital has a spherical shape, so it's sort of like a circle. And so it's quite hard to draw it on here, but I'll just draw a round circle, something like that, in the middle of this axis. So that would be an s subshell. Yeah, s orbital in that s subshell, since it only contains one orbital. So you can imagine for hydrogen, it'd probably just have that. And this would contain 2 electrons. Now, the p orbitals. Now, the reason why I've drawn this axis like this is because the p subshells contain 3 p orbitals, and they're not all in the same plane. So what we have, if we were to imagine it on a graphing context in terms of a graph, is we would have one which has a spin in sort of the y-axis plane, one which has a spin in the z-axis plane, and one which has a spin in the x-axis plane. So if we were to actually draw these orbitals, it would look something like this. So the first one I'll draw is the x p orbital, which would have it has a sort of dumbbell-like shape. So it would go out to x and back to the middle, and would do the same thing at the other side. Sometimes this is represented like more like this, so more bunched up like that. But I'll just represent it like in this sort of shape. And the next thing I'll do is I'll draw the y one. So the y one is very similar, so it's practically the same, but in a different axis. And the same goes for the z1. So the z1 also goes like in the same axis and around. And in each of these would contain 2 electrons, and these electrons would have opposite spins. So you can imagine this region would probably have an electron, and this would probably have an electron. And I say probably because these shapes are more or less regions of probability. So those regions have a higher probability of containing an electron, but it's not to say that electrons don't exist out of these areas. Electrons could exist out of these areas, just that it's very likely that they are in those areas. And so we have more electrons here and here and here, probably. And so now if we bring all of these p orbitals together to look at what they would look like maybe all together, if I draw that, we'd have the first one here, the second one maybe here, and the third one here. So it probably looks something like this, with its accompanying electrons in these different regions. Okay, so now if we were to take a look now at what element has this arrangement. Let me take a look at my periodic table. Neon 1 2 3 4 5 6. Yeah, neon has that. If we were to take a look at what neon would probably look like in terms of orbitals, neon actually has a s orbital which is bigger. It has a 2s orbital. This here which I've drawn is a 1s orbital. If we were to draw a 2s orbital, it would basically have the same shape, except it would be slightly larger in volume. So it would maybe be the same sort of shape, but it would be much bigger. It'd be a senior version of that 1s orbital. And so if we were to draw what neon would probably look like in the form of this sort of structure, starting with the s orbitals and building it up, we'd start with the S, 1s. And just to write down the electronic structure of neon is 1s squared, 2s squared, and then 2p6, and this all adds up to 10. So it's got 10 electrons in total. So this would be the 1s squared, and now I'm going to draw the 2s squared. The 2s squared. There we go. And the 2p6. So if I draw the 2p6 on here, I'll draw that in orange, like dark orange. So we've got this in the z-axis, the x-axis, and the y-axis. Yeah, I'm going to make that stretch a bit further. So that's what it would probably look something like that. And so we'd have the electrons here, 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 and here, and here. So as you can see, this is sort of what it would look like if we had the neon in terms of the building up of these orbitals to make the final electronic structure. So yeah, in the next video I'll be looking at how we can actually represent the electronic structure of different elements and ions and all of those things, and there's quite a few different types of notation. So yeah, hope you've learned something from this video.